All right. Probability quiz number 3. So here we're going to be going over some just review for probability quiz number 3 so that you can hopefully understand some of these problems a little bit more. So let's go ahead and get started. Okay, so number 1, let me move this over. It says you're picking out water balloons. There are 3 colors and 2 sizes. If you randomly pick the color and size, which of these tables list all possible outcomes? Each row represents one outcome. So rows are horizontal, so that's a row. Okay. Excuse me. So those are all listing those rows there. So we could have, so it's showing here, we could have a green large, a green small, orange large, orange small, yellow large, yellow small. Y'all get the gist. Okay, so we got 2 different tables. We're going to try and decide which one is right, or if both of them are right, or if neither of them are right. So again, we've got 3 colors and 2 sizes. So let's just go ahead and list all of our different options over on the side. Okay, so it looks like the colors they used are green, orange, and yellow. We got green, orange, and yellow for table B as well. So we've got green, orange, yellow. Okay, so those are the colors. And then the sizes they used are large and small for both of them. So that means each color shirt could be 2 different sizes. Okay, so we could have a green large or a green small. Uh-oh. We could have a orange large or an orange small. A yellow large or a yellow small. So the way I just listed it there is using the colors, okay? So if we use those colors and we look over at the side, we can see that table A has both green large and green small there, has orange large and orange small, and yellow large and yellow small. Now, that's one way we could do it. We could list them by their colors, or we could list them by their sizes. And again, there are 2 sizes. We have large and small. Okay, in the large, we could have a large green shirt or a large orange shirt or a large yellow shirt. Or we could have a small green, small orange, or small yellow. Okay, so that's listing it by the sizes. Okay, now when we go through and look, we still see, it's still only giving us 6 different options, right? But if you look at table B, it lists a green large, an orange large, and a yellow large. Green small, orange small, and yellow small. So the tables look different, but we still notice that they're technically the same, right? They're listing all those same possibilities. There's still 2 different greens, 2 oranges, and 2 yellows in table A. There's 2 greens, 2 oranges, and 2 yellows in table B. They're just in a different order. Okay, table A listed it by color, whereas table B listed it by size. But again, it's the same. So here we see that technically both tables list all of those possibilities. All right. Harry goes to Hogwarts School of Witchcraft and Wizardry. He can travel to school and back in 3 different ways: by the Hogwarts Express, a flying car, or the Knight's bus. He's decided to choose his methods of transportation to and from Hogwarts at random this year. Which of these tables list all the different ways Harry can get to Hogwarts and back? Again, each row represents one outcome. So this is the same thing, basically. All right, and I'm going to show you a different way that we can kind of look at it. So we can look at it because we're looking at on his way to and back. So to and from. And there are 3 different ways that he can do this, right? So he could go to Hogwarts using Hogwarts Express. And he could go from using Hogwarts Express, right? Okay, he could go to using a flying car. He could go from using a flying car. Or he could go to using the Knight's bus or the night bus. And he could go from using the night bus. Okay, so notice I did all that in different colors so we can see all of our different options here. Okay, now this kind of makes a nice little grid, which they did do in those videos for y'all. Okay, so we got our to and our from here. Okay, so now that I've got those colors, I'm just going to represent them that way. So we could do, so he could go to using the Hogwarts Express, and then he could come back using the Hogwarts Express, right? He could go to using the flying car. Stop. And he could come back using the Hogwarts Express. He could go to using the night bus and go back using the Hogwarts Express. Okay, again, he could go to using the Hogwarts Express and go back with the flying car. Y'all see what I'm doing here? Okay, so then he could go to with the flying car and back with the flying car. Could go to with the Knight's bus and back with the flying car. Could go to with the Hogwarts, back with the Knight's bus, to with the flying car, back with the Knight's bus, to with the Knight's bus, and back with the Knight's bus. So those are all of our different options on what he could do here. And I just did that using a simple grid to help organize my thoughts a little bit. Okay, so now we just need to go through and look. So table A, if you notice, it lists it by Knight's bus, flying car, Hogwarts Express. Okay, table B, it's a little bit more random, right? It doesn't really have as much of a order as table A does. So to Hogwarts, Knight's bus. So the night bus, it could go, so if he's going to using the night bus, he could go from using the night bus, the flying car, or the Hogwarts Express. So that listed all of those options there, right? So we're good on those. So let's check those off. Now let's see if table B has those. So Knight's bus to Knight's bus, right there. Knight's bus to flying car. Knight's bus to flying car, right there. And Knight's bus to Hogwarts Express, right there. Okay, so that one had all three. So now if we look, the next one does the flying cars in table A. So flying car to Knight's bus, flying car to flying car to Hogwarts Express. That lists all of those. Okay, so it checked off all 3 of those for us. Now see if table B has them. Again, table B is a little out of order, so let's just check. So see, flying car to night's bus. Flying car to night bus, check. Flying car to flying car. Flying car, whoops. Move that back. Cancel. Okay, flying car to flying car, check. And then flying car to Hogwarts Express. Flying car to Hogwarts Express, check. All right, all that's left is when we start at Hogwarts Express. So we got Hogwarts Express to night bus, Hogwarts Express to flying car, Hogwarts Express, Hogwarts Express. So that covered all 3 of those. So check, check, check. Now let's just make sure table B has them as well. So Hogwarts Express to night bus, check. Hogwarts Express to flying car, check. Hogwarts Express to Hogwarts Express, check. So both table A and table B did have both of them here. So this answer would show both. All right, moving on. Alrighty, so Justin lives in St. Paul and goes to school in Minneapolis. In the morning, he has 3 transportation options, bus, cab, or train. And in the evening, he has the same 3 for his trip home. If Justin randomly chooses if he randomly chooses his ride in the morning and in the evening, what's the probability that he'll use both the bus and the train? So we're not finding different options necessarily now. Now we're looking at the probability. Now we're going to need those options to find the probability. So what I'm going to do is I'm going to make that grid again, okay? Showing his options for the morning and the evening, okay? Now remember, he's got the same 3 options for both, right? So he could ride the bus, cab, or train for both. So in the morning, he could ride the bus, the train. Nope, we're going to do cab. The cab or the train. In the evening, he could ride the bus, the cab, or the train. So now let's just put those options together. So let's say he rides the bus in the morning. He could ride the bus in the evening. If he rides the bus in the morning, he could take the cab in the evening. Bus in the morning, and he could take the train in the evening. So those are all our options if he takes the bus in the morning, right? Now let's look at the cab. What if he takes the cab in the morning? Then he could take the bus in the evening. Cab in the morning. He could take the cab in the evening. Cab in the morning. Train in the evening. Okay, those are all the options if he takes the cab in the morning. And then if he takes the train in the morning, he could take the bus in the evening, or train in the morning, cab in the evening, or train in the morning, train in the evening. Okay, so we need to go through and see, well, how many options does he have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So he has 9 total options. Remember, when we're finding probability, we always use that want over total formula, right? So our total number of options here is 9. Now we got to figure out, what do we want to happen? Okay, so it says, what is the probability that he'll use both the bus and the train? Now, it did not give us any specific order here. It just says the bus and the train. So it could be train in the morning and bus in the evening, or bus in the morning and train in the evening. So we just got to find which of these options have both train and bus. So here's bus and train. Here's train and bus. So that's 2 out of that 9. So our want here is 2. So 2 over 9 would be our probability. Okay. And when you type that in, you would just type 2/9. Okay. Number 5. If you flip 3 fair coins, what's the probability that you'll get a head on the first flip, a tail on the second flip, and another head on the third flip? All right, so in order to look at this, we're looking at specifics, like when they flip heads and tails. We're not saying just 2 heads and a tail. We're saying a head, a tail, and then a head. So let's look at all of our options on those flips. Okay, so let's just start at the basic. Okay, we could do all 3 flips and get all heads, right? Or we could get all tails. We could get 2 heads and a tail, right? And there are a lot of different ways that we could get 2 heads and a tail. We could get 2 heads and then a tail. We could get a tail and then 2 heads. Okay, so that put the heads at the beginning, the heads at the end, or the tail could go between the 2 heads, right? So those are all of our options when we've got 2 heads, right? Or now let's look at what happens if we've got, looking at our tail. So we could get all 3 tails. We could get 2 tails and a head. Okay, and remember that could go in a lot of different ways. So we could have 2 tails and a head at the beginning, or a head and 2 tails at the end, or the head could go between the 2 tails, right? So those are all of our different options here for flipping 3 coins. Okay, these are all the different possibilities you can get. So if we count those, we get 1, 2, 3, 4, 5, 6, 7, 8. So again, that formula is always want to find probability over total. So our total here, total different possibilities, total different options, is 9. Now, it specifically wants a head on the first flip, a tail on the second flip, and a head on the third flip. So out of these 8 options, how many have head, tail, head? Only 1. I don't know why I said 9. There's 8 there. Scratch that. I counted 8 and then I said 9. Crazy. So there's only 1 option out of those 8 that are heads, tail, and then heads in that order. And that will not reduce. So that is your answer. So 1/8 when you type it in. All right. You're at a clothing store that dyes your clothes while you wait. You get to pick 4 pieces of clothing: shirt, pants, socks, or hat, and 3 colors: purple, blue, or orange. If you randomly pick the piece of clothing and the color, what is the probability that you'll end up with socks that aren't blue? So again, we're looking at probability, which means our answer is going to be a fraction. And to find that fraction, it's always want over total. First thing we need to do is find our total here, how many different options there are. So let's just look at all the different possibilities. I really like doing the grid, so I'm going to do the grid again. So the clothes he could get, okay, 4 pieces of clothing, he could get a shirt, pants, socks, or a hat. Okay, those are the different pieces of clothing. Now let's look at the colors. The colors he could get each of those in are purple, blue, or orange. Okay. So that means we could, so if we put all these together, we could, I wonder if I have a purple color. Don't have a purple color. So we're going to do, we'll just do this red. So we could end up with a purple shirt, purple pants, purple socks, or purple hat. Or he could get a blue shirt, blue pants, blue socks, or blue hat. Or how do you use that? He could get an orange shirt, orange pants, orange socks, or an orange hat. Okay, so those are all of the possibilities that could happen here, right? So let's count those. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different options here. And that is our total. So those are the total options, total possibilities, total things that could happen if he randomly picks one piece of clothing and one color. Okay? Those are all of our different options. Now, it says, what's the probability that you'll end up with socks that aren't blue? Okay? So now we're just looking at the socks here. And we want to know which ones are not. So he wants socks that aren't blue. So that means we're not looking at blue socks, right? So that means he could end up with purple socks or orange socks. Because those are the only options where the socks are not blue. And how many options is that? 2. Now again, this is a fraction and we always need to reduce our fractions. Notice both 2 and 12 are divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Remember, you would type that 1/6. Okay. You decided you want a plant for your room. At the gardening store, there are 4 different kinds of plants: tulip, fern, cactus, and ficus, and 4 different kinds of pots to hold the plants: clay, plastic, metal, and wood. If you randomly pick the plant and the pot, what is the probability that you won't get a clay pot or a cactus? Okay, so again, we're looking at probability. So that means we're still looking at that want over total. So again, first thing we want to do is find our total. Find all the different possibilities that there are here, okay? So let's look at first the different kinds of plants. So the different kinds of plants we could have are tulip, fern, cactus, or ficus. And now at the top, let's look at the different types of pots we could have. We could have a clay pot, a plastic pot, a metal pot, or a wood pot. I'll put that want over total up here. Okay, so now let's figure out all these different options. So let's look at our options for tulips. Okay, or I mean, we can look at it through rows, or we could go across, or we could go down. But it doesn't really matter. You're going to get the same options either way. So let's look at the tulips. We could end up with a tulip in a clay pot. So tulip, clay. We can end up with a tulip in a plastic pot. Tulip in a metal pot. Or tulip in a wood pot. Okay, those are all our options for tulips. So look at the fern. We could have a fern in a clay pot. Fern in a plastic pot. Fern in a metal pot. Or fern in a wood pot. Let's look at the cactus. Could have a cactus in a clay, cactus in a plastic, cactus in a metal, cactus in a wood. And lastly, let's look at the ficus. You could have a ficus in a clay, ficus in a plastic, ficus in a metal, or a ficus, in a wood. And that's all of our different options here. So that gives us the total number here. Notice I made them all different colors. We're not looking at the black here. That's how we found all those different options. So let's count and see how many options there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can count all of those, or if you know how to, you should have learned, hopefully in elementary school, maybe not, that if you count all the different options going across, so there's 1, 2, 3, 4 options across, and all the options going down, 1, 2, 3, 4 options going down, you can multiply them. Okay, so 4 times 4 equals 16. And 16 was what we counted when we did that. So regardless, our total here is 16. Now let's look at our want. So let's go back to the question. It says that you won't get a clay or cactus. So won't, notice I put an X under won't. That means that's what we're not looking at. So what we need to do is we need to go through and put an X over everything that is clay and everything that is cactus. So let's go through and mark out all the clays first. So all the clays are straight down through here. And now let's mark out all the cactuses. Well, one cactus is already marked out. I'll mark out the other 3. And now we just count up what's left, okay? So our options that are left, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 options that were left. So 9 over 16. Now, 9 over 16 will not reduce, so that is your answer. Remember, type it like that. So you got to pay close attention to those words. It says won't, so I marked out all the ones that did have clay and cactus, and I only counted the ones that did not. All right, if you flip 3 fair coins, what is the probability that you'll get a tail on the first flip, a head on the second flip, and another tail on the third flip? This is very similar to that other question we did. So let's look at all the possibilities that could happen here. Again, 3 flips. So we could get all heads. We could get all tails. We could get 2 heads and a tail. Remember, there's 3 different options for where those heads can go. So we could have 2 heads and then a tail and then 2 heads, or a head, tail, and a head. And then we could get all 3 tails, or we could get 2 tails and a head. And that's several different orders. 2 tails and then a head and then 2 tails, or tail, head, tail. So again, it says, what's the probability? So we're still looking at want over total. Our total is all the different options. So when you flip those 3 coins, what I just listed here are those different options, are the different possibilities that you could get. So there are 8 possibilities. Now that you'll get a tail on the first flip, a head on the second flip, and another tail on the third flip. So it's looking at that specific order, tail, head, tail. And the only one that has tail, head, tail in that order is that one. And there's only 1 out of those 8. So that is your probability. Number 9 or 8, something like that. You're at a clothing store that dyes your clothes while you wait. Okay, so this is that same scenario that we had earlier, right? So I'm going to go through and I'm going to write all of those different options out. It's just asking a different question now. What's the probability that you'll end up with an orange hat? Okay, so again, we've got shirt, pants, socks, hat. And it can be purple, blue, or orange. Okay, so we can have purple shirt, purple pants, purple socks, purple hat, blue shirt, blue pants, blue socks, blue hat, orange shirt, orange pants, orange socks, orange hat. Okay, so those are all our different options here. Again, it still says probability. So want over total. Our total here, okay, we can count the columns and the rows. So there's 1, 2, 3, 1, 2, 3, 4. 3 times 4 makes 12. So there are 12 total. If you don't understand that, just count them, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 options, okay? So 12 different possibilities. It says, again, what's the probability you'll end up with an orange hat? So let's see how many orange hats there are. Well, we could do, here's our hat section right down here at the bottom, okay? We could get a purple hat, a blue hat, or an orange hat. Here's our orange section, orange shirt, pants, socks, or hat. The only one that's an orange hat is this one right here. So there's only one option that is an orange hat. So your probability is 1 out of 12. Okay, last one. James lives in San Francisco and works in Mountain View. Okay, so we did this one earlier too, okay? He's got the bus, cab, and train that he could take in the morning and in the evening. Okay, so we're going to make that again. So we got morning and we've got evening. So we got to come up with all of those possibilities here, okay? Because we're finding the probability, right? Probability is always that want over total. So we got to find the total. We got to find all the different options, okay? So remember he could do bus, cab, or train, right? Bus, cab, or train. So he could take a bus in the morning and a bus in the evening. A cab in the morning, bus in the evening. Train in the morning, bus in the evening. Bus in the morning, cab, cab, cab. Train, cab. Bus, train, cab, train, train, train. Again, I'm just putting the two together. So we could do a bus and a bus and a cab. So bus, 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 cab, or bus, train. Or cab, bus, cab, 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 train. Train, bus, train, cab, train, train. And that's how I'm getting all those different options here. Okay. Now it says, so again, probability, so 1 over total. So we just went through and found all our different options, which is going to give us our total here, right? So again, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Okay, so 9 total. So what's the probability that he'll take the same mode of transportation twice? Meaning, if he takes the bus in the morning, that he's then going to take the bus in the evening. Or cab and cab, or train and train. So we're looking where, at the possibilities where they're the same thing. So that means bus, bus, cab, cab, train, train. There are 3 different possibilities where he could take the same mode twice. Now, 3 over 9 does reduce. Okay, both 3 and 9 are divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3, giving you the probability of 1/3. All right, I hope this was helpful. Go ahead and get that quiz done, and you'll be good to go. And don't forget to please focus on those retakes. That's what's going to get your averages up. All right, guys. Have a good rest of your weekend.